Okay, these are problems from section 3.7, and that's implicit differentiation. So here's definitely an implicit function. X squared times y plus xy squared equals 6. This is number 1 from the homework problems. And we want to find the derivative. We want to find dy dx. I think those were the directions. So the first thing we have to do is take the derivative. So we have a product rule here, and we've got a product rule here. I kind of separated them. So we've got one product rule, the second product rule. The first times the derivative of the second. So the first is just x squared, and the derivative of the second would be 1 dy dx. Derivative of y is just 1. But since it's dy dx, okay, or it's like something in the first power. And then plus the second, which is y times the derivative of the first, which is 2x times dx dx, which eventually will be 1. And then over here, plus, then I've got here the first times the derivative of the second, that's 2y, and that's dy dx, plus the second, which is y squared, times the derivative of the first, which is 1 dx dx. Okay, so now the dx dx is just 1, so I just made this y squared. This was 2xy, so I just wrote it in alphabetical order, and dx dx is 1. And this is your x squared. This stays the same, and I just put this in, again, 2xy, alphabetical order, dy dx. So these four terms simplify to be these four, or just kind of rewrite them a little bit. And then we want to solve for dy dx. We have to isolate these terms on the left, every term that contains dy dx. So this stays on the left, and this stays on the left. And then I subtract 2xy from both sides and y squared from both sides. So these move to the right and change signs. Okay, now that I've got my dy dx isolated, I will factor out the dy dx. So I only have one of those. And I end up with x squared plus 2xy. And the right stays the same over here. And if I want to solve for dy dx, I can divide both sides by x squared plus 2xy, so that goes on the bottom. And then, just to get it to match up the answer form of the book, they just had a negative sign. They like to put negative signs in front of fractions. So if I factor out a minus sign, that becomes a positive 2xy and a positive y squared all over that. So that's your answer. So not too bad, I think. It's pretty straightforward. Okay, let's take a look at number 3. And again, this is section 3.7. And again, we want to find the derivative. So we take the derivative implicitly. So the derivative of the left, that's 2y times the derivative of that, which is dy dx. And I didn't write down all the derivatives over here, all the dx dx's, but it was the quotient rule, so I had enough to do anyway. Hopefully you'll be able to follow this. So this is going to be a quotient rule. Low d high less high d low, denominator squared below. Low is x plus 1. So there's my low. D high, what's the derivative of the top? The derivative of the top would be 1 dx dx. So I just didn't write the dx dx. Okay? So it's going to be the derivative of x is just 1, and that's dx dx. Less, okay, low d high less high d low. High, which is x minus 1 times the derivative of the bottom, which is just going to be 1 dx dx, so that's just 1. All over the denominator squared. Okay? So low d high less high d low, denominator squared below. Okay? Then I can remove the parentheses, so I've got x plus 1, and then negative x, positive 1. All these ones here absorb. Okay, those are your derivatives. Okay? And then I just kind of rewrote this. This was my 2y dy dx, and then if I multiply this out, I get x plus 1, and this is negative x positive 1. And the x is 0 out, so I have 1 plus 1 is 2, so this is what I have. So I can write it over here. Now what I did was I wrote this and I multiplied both sides by 1 over 2y to cancel that, and then I multiplied this by 1 over 2y. Now these 2 over 2 is 1, so I just end up with 1 over x plus 1 squared and y in the denominator. There's this y here. Okay. So because of the quotient rule, I took a little liberty and skipped these steps here. but that should be dx dx, which would just be 1. Okay? All right, and then number 5. I think we've got time for one more. We're going to do number 5 here. Okay, and this is just x equals the tangent of y. So I just take the derivative of both sides. So if I take the derivative of the left, I get dx dx. A little more room, so I showed more detail in this one. And the derivative of the tangent of something is the secant squared of something times the derivative of that something. And since I'm taking the derivative of y, that'd be 1 dy dx. All right. Now dx dx is just 1, and that equals this secant squared y dy dx. And then if I divide both sides by the secant squared, I get 1 over the secant squared equals dy dx. And then the 1 over the secant is the cosine, so 1 over the secant squared is the cosine squared. So that was your derivative. Okay, so if that makes sense. And it helps.